Hello there and welcome to the June 2019 Core Paper 2. Here we're looking at question 5. So an engineer is investigating the motion of a sprung diving board at a swimming pool. Let E be the position of the end of the diving board when it's at rest and is in equilibrium position and when there is no diver standing on the diving board. A diver jumps on the diving board. The vertical displacement h of the end of the diving board above E is modelled by the differential equation of this thing here, and t, where t is seconds, is the time after the diver jumps. Find the general solution of the differential equation. Well, in this case here we just jump straight to the auxiliary equation. So auxiliary equation. It's only worth 2 marks this, so it shouldn't take too long. Auxiliary equation is 4m squared plus 4m plus 37 equals 0. Type this into the polynomial solver in your calculator and you'll probably get minus a half plus or minus 3i. So therefore, if that's the case, then the general solution is going to be h equals e to the minus half t brackets p cos 3t plus q sine 3t. Okay, and there we are, that's the answer to part A. Okay, so moving on to part B. When t equals 0, the end of the diving board is 20 centimeters below E and is moving upwards with a speed of 55 centimeters per second. Find, according to the model, the maximum vertical displacement of the end of the diving board above E. Well, the first thing we need to do then is plug in t equals 0, and given that the diving board is 20 centimeters below E, h is going to equal minus 20. So minus 20 equals e to the 0 is 1 times p, because t cos of 0 is 1 and sine of 0 is 0, so minus 20 equals p. Moving on to the next bit needs us to use the second bit of information, which is moving upwards, so positive, with a speed of 55 centimeters per second. So dh by dt is going to equal, now we use the product rule here, it's going to be minus a half e to the minus a half t brackets p cos, it's probably just easier to keep p in there, p cos 3t q sine 3t. If you want to substitute p equals minus 20 in at this point, you're very welcome to. And then moving on to the next bit, using the second part of the product rule, that's going to be plus e to the minus half t brackets minus 3p sine 3t plus 3 cos 3t. Okay, so now plug in 55 for dh by dt and t equals 0. T equals 0, dh by dt equals 55. So it's going to be minus a half of p and then plus 3q. So we know that p is minus 20, so minus a half times minus 20 is positive 10 from the double negative. Take it away onto the other side and you get 45 equals 3q, so therefore q is 15. So therefore we can now summarise our equation with p's and q in there, so it would be e to the minus a half t brackets, and then it's going to be minus 20 cos 3t plus 15 sine 3t. Right, okay, so that's our equation, and now we need to answer this question here. Find, according to the model, the maximum vertical displacement of the end of the diving board above E. So what this is going to be is when dh by dt equals 0, because that will be when it has its maximum height, because it won't be going up anymore. So therefore we need to work out what dh by dt is equal to. And actually we've already got a good amount of dh by dt in this bit here. So in fact I think what I'll do is I'll just start by factorising the e to the minus half t to the front, and then calculating what the coefficients of sine and cos are. So for cos it's going to be minus a half of p, that'll be plus 10, but then it's also got this 3q here, so 3 times 15, let's do that on the calculator, 3 times 15, and then it's going to be plus 10, so that's going to be 55, so 55 cos 3t, and then on the sine one it's going to be minus a half times q, so minus 0.5 times 15, and then the next bit is going to be on the sine minus 3 times minus 20, so plus 60, and that gives us 52.5, so 52.5 sine 3t. So now what we need to do is set this equation equal to 0. So therefore this is an equation that's set equal to 0, and then we can just cancel out the exponential. So it's going to be 55 cos 3t plus 52.5 sine 3t. So this is an equation where we're going to have to move stuff onto the other side and work out what tan is equal to. So if I move the cos bit onto the other side and then I move some numbers around, I'm sure you'll be able to work out that this will be tan of 3t equals, so if we move the cos first, that's going to make it minus 55 over 52.5. Okay, so the next thing to do will be in radians mode, work out what 3t is going to be equal to, and the first solution we get there is minus 0.808. Now, we're assuming here that time is going forward, so I want the next solution from there, so add pi onto this solution, and we're going to get a second solution, which is 2.3329 so therefore t is going to equal 0.7776. So therefore to three significant figures, actually no, so we'll take this value because we want to work out the maximum height displacement, don't we? So what we'll do now is take this value and substitute it into this little equation here. So therefore the height, when you type all of that into your calculator, to three significant figures, you're going to get 16.7 centimetres. So there we are, that's the answer for part B. So we've found the maximum vertical displacement of the end of the diving board above E. Moving on to part C now, just a couple of marks for part C. Comment on the suitability of the model for large values of t. Well, let's write down our model. So this is our model here. So as t tends towards infinity, in particular this function here, will oscillate, so that doesn't really affect the overall outcome. That just means it will bounce up and down. But this e to the minus half t will tend towards 0, which is what you would expect of a diving board after it's just left to shake back to its kind of equilibrium. So it will return to equilibrium. So it will return to equilibrium as expected. As expected. Okay, so there's nothing wrong with the model, so it's as expected. So there we are, that's the answer for question C, and the answer for question 5 in total there, so worth 12 marks in total there. Quite a lot for that question there, big 8 marker in the middle there. So there we are, hopefully you found that helpful. Let's now move on to question 6.